Cushioned, it won't hurt you.
So I have to throw the whole box? I can't just throw pieces of it at people?
That might hurt.
So hey, I'm Chris Short. I live in Commerce. Like Amy just said, I flew in from DevOps Days Atlanta last night. And then tomorrow I'll be speaking in downtown Detroit. So you were number 2 of 3 of talks this week for me. So quick show of hands. Who is like not in a cloud provider, not using a cloud provider in any capacity whatsoever? Okay, cool. Awesome. I don't have to go through cloud stuff and like why it's good for you.
I'd like to know your perspective.
Yeah. Like, is anybody in something other than AWS?
I'm in both Azure and AWS.
Azure and AWS? Anybody in Google?
Yeah.
Okay, cool.
Azure and Pivotal.
Pivotal. Oh, nice. Cool.
You must work at Ford.
How does everybody know this?
Yeah.
I think they're the only Pivotal customer in the area, and they spent a lot of money in it.
So we're going to talk about cloud migrations in general, like going from on-prem to like 100% lift and shift is kind of the use case I'm going to use. But just quick overview of who I am. If this would turn on. Watch, I'll jump forward 17 slides when I don't want to.
The stickers.
Yeah, it's interfering. So apparently I have to click this, and then I go, there we go. So yesterday I did my talk, right? And I'm using Google Slides for the first time. But yesterday was the first time I gave a presentation on this laptop with this tool in Google Slides. And it was the first time I'd done that talk ever as well. So I'm ironing out the kinks this week. So hopefully today this laptop won't have a meltdown like it did yesterday, because yesterday it was like flashing on my screen. Everything was fine here, but it was just nuts here, and I couldn't really use any of the guides and stuff I had here. So anyways, so I work for SJ Technologies. We're a DevOps consulting firm, but we're not like other consulting firms that will remain nameless and that we try to glob onto your revenue stream and just use that for our income. We teach people how to crawl, walk, run into DevOps practices, Agile, Lean, cloud native infrastructure if you need it. I also write a newsletter called DevOps'ish, DevOps'ish.com. Check it out. It talks about clouds, Kubernetes, DevOps, and anything else that might come up. It's a weekly newsletter, it's pretty cool. I'm Cloud Native Computing Foundation ambassador. So Kubernetes, Prometheus, the list goes on and on nowadays. I'm not even try and name all of them because we'll be here all night if you start throwing in the sandbox. But Cloud Native Computing Foundation, they're the host for a lot of open source projects that multiple companies like Google, Microsoft, everybody uses. Keeps the legal and licensing model in check, so no one company can overuse something. And then I'm also a community moderator at opensource.com. I'm a frequent DevOps Days speaker. If you are thinking about submitting a CFP to a DevOps Days, I highly encourage you to do it. If you ever need feedback on one, please feel free to email me or tweet me or whatever. I'll gladly help you write a CFP. All right, so real quick, what we're diving in today, what is cloud? Kind of important. We have a common language, a definition of what we're talking about. Should we build it versus should we buy it? Ford has kind of done both, which is cool. But you don't work at Ford, right? No, okay. And then talk about like timelines, like why they're important. All right, so here's the NIST definition of cloud. If you don't know who NIST is, they're a national security standards body. They're essentially the ones that say this is the government approved X, Y, and Z, which could mean hardware, OS, and configuration of that operating system. Most of the people go to, in the US government at least, go to NIST for recommendations on everything. So like they were the first ones to say, yes, Red Hat Enterprise Linux can be used on government networks. They said this version, this kind of configuration, so forth, so on. So I'll let you read that, or don't, because, good Lord, who needs a government definition of something? I mean, we just did our taxes, right? So we all know how fun that is. So my definition, on-demand infrastructure, no human intervention is necessary. It's redundant and highly available, meaning if one whole data center goes away, you still have something else elsewhere, if you configured it correctly. You interface with APIs for everything. You don't, talk directly to some hardware. You don't SSH into something to get your infrastructure spun up. And you force people to use those APIs. No one is actually touching the back end unless there's like a super major emergency. So it enables API-driven development, essentially, which is infrastructure as code, cloud-native kind of spinning up resources on demand or auto-scale. And that increases safety and reliability, surprisingly. What ends up happening is, you write things in a more consistent way. That increases safety. You can then iterate on that infrastructure faster, which increases safety, and you can release smaller bits of code, which increases safety, and obviously the reliability is baked into that. All right, we know what a cloud is. It's great. It's big, it's fluffy. Sounds great, right? Sounds awesome. We kind of know what we want to do with this thing, right? We don't want to run data centers of our own anymore unless we absolutely need to. We want to let somebody else do that because not every company is really great at running data centers. That's kind of why the cloud's so popular. It's because lots of companies realized over time that it makes sense to lease something as opposed to buying something. No one buys an office floor, they lease it. Some people, like Salesforce, for example, builds a massive building in San Francisco, and then they lease it back to themselves because that's easier than actually owning it, which is crazy. Or they set up another shell company to actually own it for them and then lease it from them. The question is, should you build it or buy it? And there's not always a yes or no answer to that. You can build your own cloud internally. It's totally feasible. A lot of people do it. There's tools for it. OpenStack, Kubernetes, Pivotal Cloud Foundry, they'll all help you build your own clouds. And there's nothing wrong with that. But it does enable those things like API-driven development, infrastructure as code, and all the other components that make, quote, cloud native infrastructure. Go ahead.
What's the cost for a minimal cloud if you build it?
I have no idea. I've never built one myself. As far as a fully blown out cloud, it really depends on your needs.
Right.
Well,
of
so.
course, I was just wondering minimal. So anyway, that's.
Well, you got to figure co-location is different everywhere. Some people can get a better deal than others because of who they know or what they're trying to do.
I just didn't know if it was $1 million, $10 million.
The sky's the limit. No, sorry. As far as numerical, it's really dependent upon how much you want to put in your cloud. If you want to go from your traditional, hundreds of thousands of dollars a month data center into your own cloud, nothing's preventing you from doing that. It's totally possible. If you want to take that money and give it to somebody else, that's possible too. In general, if done right, it will likely be easier in the long run to utilize an AWS and Azure or Google or somebody like that. When I say easier, that doesn't always mean compliance is easier or governance is easier. It's just you don't have a team of people that are dedicated to running cables, maintaining HVAC, those kinds of things. For the sake of this talk, we're going to utilize a public cloud provider, just because the idea of an on-premise cloud is very fuzzy, where you can actually go to all these cloud providers' websites and get costs. So there's common ways that people shooting themselves in the foot when they're going to a cloud provider, not planning how to migrate. They just say, we're just going to do it, right? Anybody had their CEO said, we're going to the cloud? Or somebody in their director, senior level person said, we're going to the cloud, and then that's it. That's all the direction you got. Yeah, that happens more than you realize. Trying to set arbitrary deadlines. Hey, we need to be out of the cloud by the end of this quarter. That usually comes right after the, hey, we're going to the cloud thing. And then not thinking about their current workload versus the people available to do the actual migration work. You still have to maintain the stuff that's making money while you're moving it into the cloud. So obviously we're at right brain networks. People do think about that. Okay, common assumptions about cloud. Number one assumption is that it saves money. Well, that may be true. It really depends on how you build out your cloud, how you get those discounts that AWS is notorious for just finding discounts for everything. Not that there's anything wrong with that. They like to get you in the door. They like to keep you there. We'll talk about some gotchas in here as well. So, if done right, migrating the cloud can save you money, right? Like you're not running or you're not co-locating all the things that require to be built and housed in a data center. If you've ever been in a data center, you know that there's heating and cooling, redundant power, generators, gas for that generator, disaster plans, all these things that come into play. Not to mention the peering agreements and then dealing with like Comcast versus so-and-so and, you know, making sure your traffic takes priority. It's a mess. So, if done poorly though, it will cost you more than what you're migrating from. The biggest thing that you hear is, oh, we're going to lift and shift to the cloud. We'll talk about that more later, but it can cost you a lot more. Some people actually think they can reduce their engineering staff because they're moving to the cloud. That's usually never the case. Usually what ends up happening is you maintain or you increase numbers. Now, if you're just moving to the cloud and not automating anything else, right, like you're still doing things like, oh yeah, we'll just use the cloud console like we do vSphere. That's going to create inefficiencies. So the biggest takeaway from this slide, I think, is do not optimize for anything that isn't important to your organization. So if it's not important to you, don't worry about optimizing it when you're moving. Obviously, you can optimize later, but you don't have to optimize while you're migrating. So some people argue that this does exist now in a certain capacity, depending upon how you build your clouds, but for years, this model of good, fast, and cheap in IT was very much not a real thing. If speed of migration is what matters to you, optimize around getting all your workloads in the cloud as fast as possible, but remember that that will cost you more money because you're not leveraging the infrastructure that the cloud can give you as far as right-sizing, auto-scaling, spinning down dev environments when they're not in use, that kind of thing. If cost matters, optimize to save money as you migrate. Move, identify what optimizations can be made, make them, move some more stuff. That'll take more time though, and probably more people, so just keep that in mind. You can sink a lot of money into a migration up front and get done real fast. Very easy to do. Hey, I have 300 VMs in this data center, I have 700 in this data center, I want to put them all on AWS. AWS has a tool to slurp all that in and give you exactly what you want. You make a one-to-one mapping for your VM size typings, and off you go.
There's no issues with data drives?
That's a different story. But typically what ends up happening is the VMware connector I know for AWS will look and see what disks are attached and create those automatically for you. It'll analyze what type of disk and the size, throw it on there. If it's SSD versus magnetic or SAS or whatever. So it'll look at, VMware has APIs, so it uses them to slurp all that data in. And literally just has this box that's sitting there offline. When you're ready to turn it on, just turn it on. It's nice, but that's not optimizing for cost, that's optimizing for speed. You can use a single engineer to do a migration cheaply, right? Like, you're just going to take a lot of time to do it. And you can use all your engineering resources to migrate quickly. But good luck getting your day-to-day operations work done too. What you shouldn't do is attempt to optimize for multiple factors concurrently while you're moving everything. Just don't do it. You'll end up spending more time optimizing, more time in both locations, and lots of lag to get introduced that way. If you move all your databases and that's the first thing you move, guess what? All that data has to go over some internet-based connection unless you get some direct link between you and AWS. Been there, done that. It's interesting. If, for example, you're doing the traditional, hey, we have VMs, we manage those VMs with Chef, Puppet, Ansible, SaltStack, whatever, and you continue doing that as opposed to having Ansible, Chef, or Puppet manage the AWS environments. You're having them reach all the way into the VMs as opposed to spinning up pre-baked images. You're not, like, that's something I think everybody can just start doing immediately before they even start their migration. If you're not doing configuration management and thinking about how do I take these tools and use the APIs prior to your migration, you're going to blow a lot of money. So keep that in mind. AWS actually recommends that you don't refactor your applications in flight. Move and then refactor, refactor and then move. Now, there's some components where, like, the cloud principles are different, right? Like, there's no such thing as a storage array in the cloud. You can make one, but they don't give you one. They give you block storage, they give you object storage, and then off you go. So, you're setting yourself up for either a very long and failed cloud migration or a lot of headaches if you try to refactor in flight. So keep in mind, you can refactor in your data center. You can break up your monoliths if you need to, a little bit, to make it easier to move. But do that in place A before going to place B. And there's nothing worse when you're migrating to the cloud and suddenly you realize your applications happens to be one of those 20% edge cases that most cloud providers don't care about. So when you hit that point, that app has to stay. And guess what? You're now a hybrid kind of cloud environment until you can refactor that app.
What's an example of something like that? What's going to cause that?
An edge case?
Yeah.
.NET, huge Windows boxes, .NET applications. I've seen those act like edge cases because what ends up happening is you need all these license agreements to run the code, to run the databases like SQL Server, and then they don't handle well with load balancing, so you have to expose them directly to the internet, and that's really like a anti-pattern for cloud stuff. You shouldn't, data center stuff these days, you shouldn't really expose boxes directly to the internet. And when you start talking about VPCs in AWS, Google, Azure, whatever they call them, that is doable, but really, really not recommended. That's just a good example, I think. You have some weird port configurations in your .NET apps. They all need to talk to different things publicly or privately, and you can't do either one for some reason. So these guys, they'll kill you. When a cloud provider comes in and says, hey, we can do all this stuff for X amount of money. You scroll down, you scroll down, you scroll down to the agreement, and then all of a sudden all these asterisks and subscripts show up. It's like, hey, what does this mean? Hey, how do I get that discount? Hey, how do I optimize for these things? They say, hey, we're cheaper, and that's why we give you a bunch of discounts. They'll highlight the cost savings. That's a winning argument for them. What they fail to mention 9 times out of 10 is how complex their pricing models are. I think Google's the only cloud provider that actually says, hey, you're not really using this huge box as capacity. They'll either send you a notification or automatically downsize that box to optimize costs. So when you see an asterisk, think of that as a touch point. Someone somewhere is going to have to actually figure out how to utilize what's going on in that asterisk. You see the word discount, you should always, always, always ask, how is that determined? This is an actual thing from a real live, slightly confidential agreement for a cloud migration for a company I used to work for. They had to do a 3-year prepaid reserve to get the discount. Buy hundreds of VMs prepaid. Try to get that past your CTO.
It's actually higher than that discount.
Right. So when you do this, it comes up to 3 years of data center bills, and people ask themselves, why are we moving?
But you can play games with that stuff.
Oh, you can totally play games with it. Yeah. I mean, there's we'll talk about Capex
There's
and OPEX.
arbitrage and
Yeah.
all kinds of brokering, so there's all kinds of stuff.
Yeah, I mentioned that a little bit later. Yeah, it's fun. So those splats, all those asterisks require work. The idea is to create the logic to automate that work for you and understanding what that automation will look like as time goes on. AWS will work with you on it. They're more than happy to even give you credits when you realize, holy crap, we got this box that's been bouncing all day, blowing away CPU resources. We didn't even know. They'll totally discount that off your bill for you. If you detect it and figure out how to fix it so it doesn't happen again, they'll do that for you, no problem. So the next assumption is not running your own infrastructure reduces your bottom line. I mean, it sounds logical, right? But Capex and OPEX, and I'll go over what those terms are if you're not familiar, they still apply in the cloud. The expectation versus the reality is that if you help a cloud provider figure out how much money they're going to spend, they're going to help you figure out discounts better. They're going to give you more as you help them, like the previous slide showed. Give us 3 years up front, we'll give you a big discount. The 6 P's still apply in the cloud too. Proper planning prevents piss poor performance. So Capex and OPEX, totally different things. The capital expenditures, Capex, are things like servers and storage arrays, big things that you acquire, and then guess what? They're considered an asset. And as their lifespan is measured in years, they're depreciated. And as that depreciation goes, it's essentially a tax credit. So your Capex is very much a CFO game with the IRS, and that's fine. But those capital expenditures are classified different. People sometimes talk about the color of money. Capex money is a certain color, OPEX money is a different color. That Capex money is, they know they're gonna get a tax break on that. But when you're not buying your servers, where's the tax break come from? Do you get one at all? Now there's ways to turn cloud spend into Capex, right? That's all financial, regulatory type stuff, so there's ways to game that system. But what it comes down to is you gotta work with your finance team to figure out how to do that. Is there a question?
I was going to say, if you're a publicly traded company, Capex does show up on your
Right.
stock market.
Oh yeah. Like
Stock valuation.
your Capex stuff is always reported.
It's not just taxes.
No, yeah. There's a lot of incentive to optimizing Capex versus OPEX. It just depends what do you want to make your stockholders happy? Do you want to make your tax person happy? Yeah. Operating expenses are, ongoing costs to run the business. Things like rent, insurance, travel. Those are all operating expenses. There's all kinds of games that can be played there too. OPEX is tax deductible in only the calendar year it's purchased. So if you ever run into a situation where hey, we need to buy a bunch of office supplies for the end of the fiscal year because there's a little extra money left over, they want to spend that and get the tax break that year as opposed to a year from now in the calendar. So, Google and Amazon are spending tens of billions of dollars this year in Capex. $160 billion, 2018 public cloud capital expenditures. That's all the public clouds. Google spent $30 billion in Capex last year alone. That Capex are the custom servers they're building to put in their data centers. They're the custom storage arrays they're putting to make their object stores. The expectation is that when you help a cloud provider better predict their Capex, they'll pass some of that savings back to you. And if you do it right, the savings will be huge. And they'll give you things like enterprise support and all the other fun bells and whistles that'll help you out when in the middle of the night everything breaks and you need to figure out why. Go ahead.
How do you help them predict that?
You say, I'm going to pay for 300 VMs of this type
I see.
for the entire year up front.
Make a contract.
Right.
I see.
Yeah.
Contract. Okay.
Or you do reserved instances, or there's a different name for it in every cloud. So the 6 Ps matter so much when you're going to the cloud. You can't just jump overnight, do what the CTO or CEO says, hey, we're moving to the cloud, and the next day you're over there. You got to figure out what moves in what order and why. very important. Iterating quickly once you have a plan is great too. So knowing what's next, figuring out, oh, we have a bottleneck, can we move this thing now as opposed to later that's coming up, is very, very helpful. But you have to plan those cost savings into your migration as well. So you're gonna have to do some work to say, hey, let's optimize this thing, for, hey, we chose this size VM to migrate this kind of, or this size EC2 instance to migrate this size VM. We actually need a lot less than that because of the CPU type or something. So that kind of optimization is totally feasible, right? Migrating from one size EC2 instance or VM type is super easy to do in the cloud to another, super easy. We'll talk about some of the details of planning a little bit later. The next is something is lift and shift is a really good strategy towards moving to the cloud. Yeah, it's a really good first step towards moving to the cloud. If you do it, like I mentioned earlier, if you do it poorly, it will cost you more than actually staying in your data center. I've seen it happen several times. Lift, shift, and optimize is the new black, right? Like, don't just sit there and say, oh, everything's in the cloud. Nope, you got to optimize it first before you say everything's in the cloud. Plan and execute how to get those discounts. So take all, if you're not familiar with the term lift and shift, take all the things in the data center, put them in the cloud. Don't worry about, hey, they're MS SQL servers in the data center, they're MS SQL servers in the cloud. That's a way to stay, kind of cloud agnostic, but there's a reason things like DynamoDB and Cloud SQL exist, to take place of those big, huge servers and use more commingled infrastructure. And they give you a discount, so you just say, hey, I need about this kind of IOPS or throughput or whatever the metric is you need to hit for a database server as opposed to running your own.
In your experience, when people move that, do they do that over the internet or physically?
They will,
ship their
so again, it's
guys?
lift, shift, optimized, right? They'll move the server in with the intention of shutting it down after all the data gets pushed into the new DB system. I mean, you can do that kind of snapshot and then restore, but then you're doing replication type stuff over the internet, and that's just very slow, yeah, depending upon the size of your database, right? If you've already broken everything up into microservices and your databases are measured in gigabytes and not terabytes, that might be feasible. It really depends on how big your DBs are. But
if you optimize for that cloud provider, then you're stuck in that cloud.
There's that too.
Right, so if you look at these large companies like Ford, they're not going to do that for all their applications.
Yeah, and if you're going to Oracle Cloud, they're going to jack up your bill, so.
Oracle's going to
No offense to Oracle.
Well,
yes, all the
there's
offense to
IBM
Oracle.
Cloud that nobody even talks about.
Which product is that called? SoftLayer, Bluemix, now it's IBM Blue or something like that? I don't know. They've had like 7 clouds. It's all Watson at some point, right?
And then they're quantum computers. They're in the cloud. You can access.
Right, it's just a shitload of computers, not
Right.
really like
Right.
quantum.
Cloud,
Yeah. All right, so you tell someone you're doing a lift and shift in your C-suite, you're like, great. Well, tell me when that's done. And you finish, and you're like, yay, we're all done here. But then you get the bill. And you're like, holy shit, it's $1 million for this month. That's bad. Because oftentimes what happens is, Amazon does this routinely, right? They say, oh, you're spending this much money in, XYZ data center. Well, we'll give you a discount to come move. Just off the top, just to move. Just to come see them. Well, they give you that discount in the form of credits. And if you blow through all your credits in the first month, those credits were going to last a year, that's bad. That's a really bad metric to hit. You don't want to blow through all your credits in the first year, or the first month, especially if they last a year. So what do you do when the bill's sky high? Keep in mind, some clouds just want to watch the money burn. They literally don't care. May or may not be a company that's called Amazon. Like I said, Google will actually optimize stuff for you if you let them. Amazon, you got to work to get those discounts. So, one thing I experienced directly is, I'm sorry, I have to mute this because apparently my family's having a conversation. So one of the migrations I did, we planned on discounts, but we didn't plan how to execute them. And that scenario where it was like, oh, we just blew through all of our year-long credits in the first couple months happened. Because we forgot to read the asterisks and figure out how to make those asterisks happen. And AWS was like, hey, let's do weekly meetings to work on this stuff. And we were always too busy doing the ops work to attend the meetings. So it ended up at the last minute we started optimizing stuff. We didn't plan to maximize the convoluted discount scheme that AWS gave us. So optimize often, right? As far as your bill goes, right? Like if you said, I need 100, reserved instances, and all of a sudden you're using 200 and 150 of those are not going away, buy 150. Constantly do that, back end kind of mathematical operation. Your finance team will love it if you kind of establish that same language early on. They'll help you figure out, hey, numbers, and I know data center stuff. So they'll build an Excel spreadsheet like that to help you figure out what's staying, what's not staying, where to get the most money. But you got to get them involved early in your process. Don't let them come to you later on and be like, why is this bill so high?
In terms of optimization, have you done a lot with like Cloud Health or different companies that specialize?
So yeah, that's a good point. And I don't mention that in here, but I'll talk about it, sure. There's a bunch of companies that will help you optimize your cloud spend. And what they end up doing is they take a percentage off the top of what they saved you. So if they walk in and say, hey, install this agent on this system and we'll go through your AWS account, we'll figure out all these things that you can optimize, that's the metric. Like they might find one thing, saves you $1 million if you just would have looked through like a list of 10 things on the AWS blog to look at. If it saves you $1 million, they're taking 10% of that.
And those companies are ripping you.
Yeah, I mean, there's some good ones out there, right? Like they tell you up front, like, here's the checklist you should do before we come in.
Right.
There's actually some people that give you the checklist and say, make sure this stuff's covered before we show up.
There's a lot of tools out there.
Right, there's a lot of tooling, there's a lot of good. The AWS blog is constantly updated and they talk about how to save money often. Same with the Google Cloud, same with Azure. Read up first, do your research first. Make sure you're dedicating time during your and before and after your migration to do that research. That 20% time really, that Google has supposedly, they don't have it anymore. That matters, right? Like you have to do research to figure out how to optimize some of this stuff. So, here's kind of a strategy that I came up with. They kind of work for us. It could be different for you. Lift on Monday. Do all your moving of VMs or services or whatever it is on Monday. Put them in the cloud. Shift everything as far as like traffic direction goes on Tuesday. Make sure there's no errors. Make sure everything's performing as it should. Keep an eye on everything Wednesday and Thursday. Make sure the traffic between your data center and the cloud is how you expected it to be. Make sure that there's a lower error rate than what you expected, and then optimize that stuff on Friday. Like guaranteed for a fact, you have 2 days of good data, optimize that. Now, this is where it kind of falls flat. If you're a company that gets a lot of business on Super Bowl Sunday or a holiday, that's hard to optimize for. But you're probably already in the cloud and you're probably already auto-scaling for that stuff as it is now.
So when you're talking about moving to the cloud, you're talking about 50 VMs, 100, 1,000, 10,000?
Doesn't matter. However much you're
You
moving.
do that in a week for 5,000 VMs?
No, you're not going to lift not all the
You're gonna do
5,000.
segments.
You're going to do segments, right? Like break it up
Right.
so that you can actually use this model. Move everything over on Monday, Tuesday.
What's the good segment? What's a good number? Segment.
It really depends on your services, right? Like if you have, 5,000 servers that are all serving like one API or something, great. Like you could lift and shift that however you want because you could just literally put a load balancer in front of everything and off it goes.
That's a web servers.
Right. So if you have, huge database servers that are being hit by all these disparate applications, you got to handle that a lot differently. You might move 1 out of 7 every week just to make sure the load's okay.
Yeah, a lot of the on-site servers have long dependencies of the servers. They can have hundreds of servers they're attached to.
Right.
And it's a cluster.
One company I
We
work,
talk offline, but
yeah. One company I worked with hadn't done anything in their data center. They literally were just printing money for 10 years. No code application, optimizations, no nothing. They're like, holy crap, we got to do something because we can't find developers to work on this stuff anymore. Yeah, well, guess what? Now you're moving to the cloud, you're trying to refactor your code, you're trying to figure out, because you let all the developers go, or they found better jobs to do because you decided not to increase their pay even though they're in higher demand. Yeah, now no one knows how the whole thing was put together and now you're trying to move it. Yeah, like stuff like that happens more than you realize. So take the time, create that feedback loop. You know, DevOps is all about feedback loops. I think this is the best thing you can do for yourself is install a cadence, install a pattern to where you know that your feedback loop is going to happen. You know when it's going to happen, how often it should happen. It doesn't have to be every week. It could be once a month. It could be every day if you want. It really depends on what works best for your organization. And like the biggest part about clouds, remember how we went from bare metal to VMs, VMs to containers? Like how the density of 1 square foot of data center space gets you X amount of compute, memory, and disk. You're increasing density when you go to the cloud. Don't worry about having this burstable system. Have a burstable array of systems. Auto-scaling groups, huge deal. Run the smallest possible footprint you can and have it auto-scale as demand comes in. But then there's some tricks around that too.
Well, you have to write the applications for that.
Right.
What about shared tenancy? Is that,
You're in shared tenancy altogether and you're in cloud anyway, right?
well, there's selections.
I mean, you can get like some, private instances, but that instance is where the privacy ends. That network's not going to be private.
Right.
So yeah, if you want to call your cloud move a SaaS application move, that sometimes works better for your security team. Because in general, security organizations are okay with SaaS providers, not okay with cloud providers. It's just some weird legality thing. 'Cause SaaS applications have been around for a longer. It's a matter of time, essentially.
So you mentioned that there are certain companies who kind of help organizations optimize the code after you move to the cloud. So I was kind of wondering that if it is better, so once I have moved to the cloud, I have to do it properly, otherwise it's going to cost me more money.
Right.
So why are there organizations which can help you, optimize before you move to the cloud, so that your lift and shift has a better chance of?
Shouldn't you be doing that though, if you're the company?
I don't think so. They're too busy doing other things.
Right. So yeah, if you're bringing in a team of people to refactor your app.
Yeah, we have let our developers go.
Okay, here comes the real reason why I'm behind the question.
But if you're back to that, you're not lift and shift anymore.
No, if you're talking about optimizing before lifting and shifting, at some point in time you're gonna have to get developers' hands dirty in the code,
I
right?
mean, mostly the question is around cloud enablement.
Right.
It may not be a lift and shift, but
Mhm.
it's about leveraging and providing a platform so that we can auto scale,
Right.
right? So,
Yeah, you're gonna have to recode things.
You have to rewrite everything. That's why a lot of companies are staying with IIS, and it's complex.
Yeah.
It's a big issue.
I mean, that's when you look at, do I just do a private cloud, run my own cloud?
And I
Yeah.
think there are companies out there that do scan their infrastructure to try to figure out how to optimize for the cloud.
Yeah, AWS will do that for you, right? Like if you put enough AWS hardware in your data center, they will pick up everything.
They'll scan what needs to be done, what's the dependencies of all the applications as well.
They'll figure out network traffic and everything.
I'm just kind of curious to see.
I don't know how
I've
they
never
do
heard of
it.
AWS doing that. I've heard of third-party
Let's put it like this. The big companies that do that are also the ones that pull up that 18-wheeler truck snowball thing and dump all their data in that. That's how they migrate.
I'd be curious.
Right, it's very costly, but yeah, they can figure all that
They
out.
get to also do that stuff live as well, right?
Mhm.
Sometimes, so it's a lot more complex than.
Yeah.
I mean, I work with large.
I mean, you're talking about installing agents and APMs and everything, right? Like everything gets something sniffing at that point.
And the security won't let you do that, so you can install agents, you gotta wait for a year of certification at Ford. Or two.
All right. So planning is everything. I've mentioned that a few times. Plan, do, check, act. Very big deal. I think that's from Lean or Six Sigma. Like, that's how you should do it. Monitor all the things. Find your holes on monitoring and fill them. When you're moving to the cloud, there's more stuff to monitor. Most cloud providers give you tools to monitor with. Make sure you're using them. Embrace cloud native concepts and move them, or move to them, right? Auto-scaling groups, huge deal. Business needs are, business logic, business metrics are all what drives everything, right? Like, our customers are the business or people that actually buy stuff from us. They're what matters. So yeah, okay, Plandocheckact is from Lean. You tell I made these slides a while ago? Scientific method that I recommend for cloud migrations, right? It goes back into that feedback loop. Plan it, do it, check it, and then act on it if necessary. And then repeat, right? Like, you're not gonna don't think of Plandocheckact as the entire migration. Think of the migration, break that up into smaller iterative pieces of work, and then migrate as necessary. Monitor as much as you can. You should be the freaking NSA when it comes to your cloud. AWS should not pick up something and call you and be like, hey, what's going on? You should know that way in advance, and you should call them and say, hey, we got something weird going on. Getting all the data is vital. Slurping all that data in, using time series databases, all these great monitoring tools we have nowadays. I know it's a convoluted space, but you got to get into it. You got to get your hands dirty. It's hard to find outlying issues when you don't have all the data. Make sure you monitor your bills and your spending with those same monitoring systems, right? That way you can correlate that data. Hey, we had a huge decrease in spend. What happened? Hey, we had a huge increase in spend. What happened? You can line all those graphs up and see it as it's going along. Be able to correlate events at the provider, like outages or weird configuration issues, like somebody dumped S3 in US East 1 somehow a couple of years ago. Be able to figure that out before it actually impacts your business so that you can move or mitigate as best as possible. And use business logic to augment that data too,
So
right?
You're talking about anticipating failures.
Yes.
And, I mean, imagining events, but when you said S3 having problems, how often does that happen?
I think once every 7 years, I think is what they're average right now, right?
Okay. So, I mean, maybe that's some legitimate concern.
No, that is a business metric for some people, right? Like, we need more than once every 7 year outage. But keep in mind that one outage every 7 years was like a whole day.
Cloud providers don't have any SLAs.
They do have SLAs.
They do.
But what they do is they usually kick it back to you in like credits. So you got to stick with them
So
to get that money.
That's been the reluctance for many years is why a lot of these companies have not done it because of the SLAs.
No, they have SLAs, absolutely.
Yeah, they totally have SLAs. Yeah, they have SLAs, they have compliance, they have governance, they have everything now. You can get yourself a fully compliant
Not the
HIPAA cloud.
SLAs that the Fords and the GMs are used to.
4 nines, I think, is a lot better than Ford and GM can do. That's the lowest SLA I think AWS gives anything.
Correct.
But it's probably gotten better in the last couple of years.
So yeah, use business logic to augment that data. All of a sudden you had a huge dip in profit. Why? What happened? Was it anything that you did? Did latency increase in your web applications? It happens. Amazon has metrics for how often somebody buys a book after they click it. They're sending you pop-ups to your phone after you buy something for something else to buy. They know how often you're going to click that, and they know how often you're actually going to buy that before they ever send the notification. They have data, they use it. You should too. Embrace the cloud. It might be stormy, it might have its parts that are kind of, edge cases. Elasticsearch or Elastic Cache on AWS is definitely one of those edge cases. But plan for points to refactor your application while you're thinking about moving it as well, right? Like, we know we can refactor this, we know we can refactor that. And then guess what? I don't care how well you know your infrastructure, there's going to be some refactor thing you don't even think about. Because we all assume that we know things that may or may not be true about large infrastructure. Things like converting cron jobs into like Lambda functions, I think is one of the coolest things that we can do now with the cloud, right? Like, we don't have to have a server running cron jobs. You could spin up a 3-node Kubernetes cluster and have that run thousands of cron jobs for you, and guess what? They're highly available, they're always going to run. Super simple to configure cron jobs in Kubernetes, just like it is to configure cron jobs on a server. Downsizing instances and disks on the fly, that thing that Google can do for you, Build something like that into your infrastructure. Optimize your block storage. Figure out your message queue sizes and utilization. Make sure you're not spending too much there. Or, if you're running Kafka in your data center, why not use SQS or something else with playback if you need it? Make sure you're using the functions specifically designed for you. SQS is a lot cheaper than running a huge, highly redundant Kafka cluster in the cloud. Lay out a container strategy. Figure out how to increase density that way. So business needs, like I mentioned, are everything, right? That cool new feature comes after the things that pay for people's food and shelter. Right? Just because AWS released this cool new thing, we can now, mine Bitcoins in the cloud if we want to. Hundreds of GPUs in a box. Yeah, no, it's
Promise.
sounds like experience might be talking.
ASICs put the GPUs out.
Oh yeah. No, FPGAs are anyways.
ASICs.
Yeah. So, business logic monitoring, things like, hey, we know that, what is it? There's an airline out there that says if we open the door to the jetway within 60 seconds, if we do that consistently throughout a whole year, that'll pay for 3 737s for us. It's like saving that time, getting that plane back out in the air, serving customers faster, actually saves them money. Like, they know that. Measure that. I don't know how the hell they measure that or how they figured that out, but they did. There'll be many shiny objects to tinker with along your journey. Try to resist that urge to tinker. People need, food, water, shelter more than they need, some fancy new thing that's cool. So I champion Kubernetes all day long, but if your organization doesn't have a bunch of containers running already, you probably don't need Kubernetes. If your error rates are high for critical functions, make sure you know about that. Oh, sorry. Remember that you still have to build that rapport with finance like I talked about. Like, finance is part of the DevOps process too. It's part of your migration process. They're a silo too. You have to crack the walls between IT and finance, because keep in mind, for decades they were fighting against each other constantly. How many people that are building VMs on a regular basis ask the developer for specs? No one? People writing code, they don't dictate the specs of the servers to you? Good. If they are, well, now you go back to them and you say, hey, you thought you needed, high memory box. Actually, you just need high I/O. Optimize for that. Don't let them dictate, we have to have 17 CPUs and 48 gigs of RAM. Tell them what they need. Show them that they can auto-scale and it's not a problem.
Do you recommend testing various instances to find that? How do you really optimize? Do you observe the behavior?
Yeah, you got to monitor for it, right?
Monitor and then make intelligent decisions based on that? Okay.
Yeah,
Because you can experiment a lot. You can spin things
you
up
can do
in
tons of
different
experiments,
sizes,
but 9 times out of 10, you can tell an application's memory, CPU, or I/O disk bound very quickly. So optimize for that situation.
But you can't optimize you can't measure what you don't have.
Right.
Well, what you don't know is going to happen either. Because you could have 100,000 people attaching your website. You got to have an auto scale, right? Because it's
Right.
going to get the whole server down.
Yeah. So vendor lock-in is real, right? Like, as you mentioned, going to some of these proprietary services, DynamoDB, GKE, I don't know of a proprietary service that Azure has, but I'm sure it's got, AD integration, right? Like, that is a form of vendor lock-in. It sucks to learn that there's something better out there that you could utilize, but you can't move to it because, you've dumped all this time, money, effort, energy, and optimization into some edge solution.
I think that's why some of the cloud providers are good at something, so you use those cloud providers for that.
Yeah,
And
like,
then the others, right? Whether it's data analytics or or IIS or whatever.
Right. Pop quiz.
PaaS or-
What was the first AWS service to launch? Anybody know?
SQS?
SQS. Yes. SQS was the first Amazon service to launch. Nope, it was not S3. EC2 was right behind it, and then S3 was right behind that. Yeah, everybody assumes, well, not everybody, the majority of people think it's EC2. No, SQS is what Amazon.com was using the most, so they launched that first. Or whatever their message queue thing was called when it was Amazon.com. So, don't fool yourself, right? Like, Microsoft, Amazon, and Google are thinking of ways to make it hard for you to change cloud providers. They do that through discounts. They do that through tooling. They do that through services. They're trying to keep you a happy customer, and they're also trying to keep you from picking up everything and moving it over someplace else every month. The more reliance on basic network compute and disk you have, the better. But to think multi-cloud right now, I think it's a little early. Internet infrastructure between the cloud providers is not something that you can sit there and say, yep, I have a load balancer sitting here in this cloud and it talks to Azure and Google and Amazon, and we just load balance everything dependently, right? Like,
And when you're talking about it's containers, really, when you're talking about more reliance on things that are not basic, you're down to containers.
maybe. Some people think that they can load balance their databases across cloud providers. Good luck.
Very difficult.
Yes, exactly, right? Because you're trusting the internet to route traffic for you, essentially. That's the big thing, right? Like, routing over internet backbones is not fun. Routing inside someone's, BGP gateway, that's easy. So there are minimum viable products masquerading as full service offerings in these cloud providers. Amazon's notorious for it, right? They'll slap a beta label on it and be like, nah, we've had it out here for 3 years, but it's not really fully supported. So good luck. Oh, you were the first customer on it. Sorry. I'm not trying to bag Amazon. They're the oldest provider, right? Like, they're the biggest one. They have, learned the hard way sometimes. Those are the sharp edges of the clouds, right? Like, the things that all of a sudden they're like, yeah, they're new, they're awesome. And then they're like, oh, they're not going to be fully supported a couple years later.
Postgres for Google Cloud just went publicly available 2 days ago.
Right, like it's been out for how long? Like 3 years or something?
It's probably still beta compared to the others, yeah?
No, it's probably way better than the others.
Oh, yeah?
Yeah.
Wow.
That's because they had the time to do it right. Putting a label on it saying beta keeps people away. Saying it's ready to go and then slapping a label on it, it's like getting kicked in the head.
Yeah, I had a customer that went to Google and I think they had a lot of issues migrating. So they had networking issues. There's a lot of things that they're used to right on their, but anyways, we'll talk offline.
Configuration's everything.
Yeah.
Eat your own dog food. The best way to avoid lock-in is to not move too far from that core functionality. Take the time to research the specialized tools before building your business around it. Keep in mind, like, all these services that AWS and Google and everybody else provide, like, it's built on top of their EC2 instances or VMs. It's built on top of their object storage. This is the best thing I could come up with for dog fooding. This is my son and my dog playing with each other a couple months ago, so.
Or a couple days ago.
Yeah. When I made the GIF, it was a couple months ago. It could have been yesterday. That's what I should tell people. Next time I do this talk, like someplace southern, yeah, I'm from Michigan and it snowed yesterday. But you can build your services and your core offerings and stuff on the same things they do, right? Like, that's what Netflix is doing, right? Like, they're not taking all this CNCF tooling and putting it in their infrastructure. Some places they are, but Netflix builds all their stuff internally. They are now branching out and testing other cloud providers. AWS, they've worked with them for years.
What's an example of moving away from the core?
Like going into like DynamoDB or SQS as opposed to just building something yourself. Right, so there's, like, again, it's that trade-off. Do we build it ourselves or do we just buy it?
So would you consider MongoDB the same way?
As far, like, if a service company or if a service provider is giving you MongoDB, giving you some way to interact with MongoDB, yes. If you're spinning up EC2 instances and putting MongoDB on it yourself, no. Does any cloud provider offer MongoDB? don't think so.
I thought I saw it.
Is there? I don't know.
I don't want to say.
There are some white box services that you can get that just put in a configuration, and I'll give you an address to use.
I think Mongo's has their own that's called Atlas, I believe.
Yes, that's right. That's what I heard about.
AWS
Yeah.
or Google, neither of those.
Yeah, I didn't think so.
As far as if you're using containers, are you fully portable to other cloud
No.
providers? No, you're not either.
I mean,
It's just
it depends on your implementation of those containers, right? Like, can you lift and shift your entire Kubernetes cluster, your Docker Swarm cluster, all your Docker engines? Can you do all that all at once?
Yep.
Probably not.
Well, Valus has told me 2 months ago they're going to have all their containers moved to on-premise within 2-3 months. And they got like
That's totally
thousands.
feasible.
I don't
That's
know how they're doing it
totally feasible.
from AWS.
Yeah, totally feasible. But keep in
From
mind,
the cloud to their
from the cloud to
on-premise?
on-prem, yeah.
Wow.
Once you get everything in a container, moving it is easier.
But then I don't know why you would want to do that.
Because they bought their data centers and that's what they're doing. That's what they told me. I had 2 customers that.
CapEx versus OPEX. They were spending so much money on OPEX in the cloud, they said, well, we can amortize this hardware over 10 years.
It
And
goes to the optimization piece, right? I think companies are quick to go to the cloud, but they don't spend time. And the tools aren't there. There's a lot of tools, but there's nothing really governing this whole strategy, in my opinion. Interesting.
there's fascinating ways when money
There's
and
a lot of stuff
IT
you
come
don't
hand in hand.
optimize,
Yeah.
right? If you got any ideas, that's where it's at.
So here's a use case for vendor tooling, right? Like augmenting staff through vendor tooling is okay. If you say, hey, I'm going to build all this stuff internally, but I need 300 engineers and you have 10, that's a problem. Use the vendor tooling at that point. Buy it, figure out how you're going to build it later. Figure out how you're going to move containers from AWS back into your own data center. But put something in the backlog saying, hey, this could be technical debt at some point. Hey, this could be something we could build ourselves in the future. If your team's missing a skill that you need to build something on your own, put a bug in HR's ear. It takes months to find these people nowadays. You're going to need to get out there, and if you're seriously considering running your own SQS style service in the future, you're going to need somebody that's really good at message queues. It's going to take months to find that person. Just keep that in mind. You can probably build it better for your business yourself than a cloud provider can. But can you build it as quickly and as reliably? Maybe not. So buying and then building, that's pretty good strategy, right? Like startups do that all the time. Facebook didn't build their own data center and then build Facebook. They co-load a bunch of stuff, they leased a bunch of servers, and then they started building their own data centers. All right, it's been almost an hour, which is a long time for me to talk. So, cloud, great, mostly. Money is good, but try to keep more of it yourself. Planning is awesome. Vendor lock-in, but not terrible, right? There's reasons for using those vendor-centric tools. But I think the biggest thing to remember in any cloud migration is that the tooling is not the hard part. Tech is not hard. Tech is easy. Meat is hard. Humans are the difficult piece. Trying to figure out who's going to take vacation during your 6-month cloud migration is like a big deal, right? Like, because that skill is out. Try not to bug people on vacation. Here's 2 quotes. My friend Nermal, Bridget Cromhout, both saying essentially the same thing. The computers are hard. Or, I'm sorry, the computers are easy. The people are hard. Make sure you're managing your people as effectively as your data centers. That's it. Thank you for your time.